Hi everyone, this lesson 4.2 is going to look at some ways that we summarize or interpret data sets. So it's an extension of your first lesson. So 4.1 looked at taking raw data and transforming it into usable format. So a histogram or frequency distribution where we bundled up the data into individual bins. Okay, so we categorized it by certain sizes. In this instance, we're going to analyze the data a little bit further. So we're talking about, at the start, mean, median, and mode, as well as the range of the data. At the second half of this lesson is going to talk about standard deviations. So our first piece, mean, median, mode, and range. Let's start with that. So the range is simply the difference between the highest and the lowest value in your data set. So if you had, let's say you had simple data, okay? 6 data points, 1, 2, 3, 4, 5, and 6. Your range would simply be the difference between the highest value and the lowest value, which in this case is 6 and 1. So your range would be 6 minus 1 equals 5. So you're talking about the overall kind of difference between lowest and highest value, or how spread the data is. All right? So that one is simple enough. The mean is the average of all the values in the data set. Okay, so you do that by adding up all of the pieces of data and dividing it by the total number of values. So going back to this simple example that I have here, I have 6 numbers, 1, 2, 3, 4, 5, and 6. So our mean would be 1 plus 2 plus 3 plus 4 plus 5 plus 6. Divided by the total number of values that I have here. In this case, we have 6 values that are being added up. If you add these up, okay, on the top, we have 21, and that is divided by 6 values. So that gives us a mean of 3.5. Okay? So simple, pretty straightforward. The mean or average you probably use a lot. The range is something that you might not think of the term range, but you probably look at what the maximum values are in data more often than you might think. The next two terms are the median and the mode. So the median looks at the middle value in your data set. So you start with the median by arranging your data in order from smallest to largest or largest to smallest. And the median is the middle data piece. Okay, so for example, if you have 21 values or 21 pieces of data, it would be the 11th value because that would fall right in the middle. If you only had 20, that means there isn't a middle piece of data. So anytime you have an even number of values, there isn't a median because there isn't one number that you just go to and say, oh, this is the middle. So what you do is you actually find the average of the two data sets closest to the middle. So that would be number 10 and number 11. So if you want to see this in practice, I have another data set here. Okay, I've ordered it, okay, from smallest to largest. So I have 1, 2, 2, 3, 4, 4, 4, 5, and 6. So if you add these up, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So because they're arranged from smallest to largest, the median is the middle value. So if you have 9 terms, it would be the 5th value. And that's because there's 4 values to the left of it and 4 values to the right of it. So your median here is 4. Okay? The term we haven't talked about yet is the mode. And the mode is simply which value appears most often. So in this case, 1, 3, 5, and 6 only appear once. Okay, so 1, 3, 5, and 6 appear once. 2 appears twice. And 4 appears 3 times. So the mode here would be 4. Okay, if you have multiple values that appear that many times, let's say there was another 2 here, then your mode would be numbers 2 and 4. Okay, so the mode doesn't have to be one specific number, while the mean and the median do. All right? Okay, so let's look at our first example. One of my math classes, I will not tell you which math class, or maybe I'm making this up and it wasn't actually test results, but they had the following grades on their latest test. And I have a list of values here, okay, 12, 10, 13, 13, etc. What I'm asking you to do is calculate the range, mean, median, and mode of the data. Okay? So we'll start with the range. Okay? So the range, remember, is your highest value minus your lowest value. So what I like to do for that is scan, okay, from left to right as we start. And as I have the smallest value, okay, I'll keep going from left to right until I find the smallest one. So we have 12, 10. So 10 is my smallest one that I have. 13, 13, 13, 11, 12, 11, 10, 10. See, I'm just checking to see if there's anything smaller than 10. I'm going to keep going. 12, 12, 11, 8, which is smaller. So currently 8 is my lowest number. 9, 9, 11, 12, 13, 9, and 9. So my smallest number is 8. Okay. And I know it's the larger minus the smaller one. So my largest value, we have 12, and then 10 is smaller. 13, which is larger, so now my highest number is 13. 13, 11, 12, 11, 10, 10, 12, 12, 11, 8, 9, 9. Keep going, 11, 12, 13, 9, and 9. So nothing is larger than 13. So my largest number is 13, meaning my range, 13 minus 8, is equal to 5. My mean is equal to the sum of all of these terms divided by our frequency. Well, if we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 for our frequency. So I'll write F equals 20. And if you add them up, what it's going to look like is going from left to right, 12 plus 10 plus 13. And it continues to add up all 20 values with your calculator. And it's divided by our total number here. Okay? So if you add up all the numbers, you get 218 divided by 20, which gives you a mean of 10.85 using your calculator. Okay? Our median and our mode are calculated by first arranging this data. So we know our range is 8 to 13. So what I do is you arrange the numbers from smallest to largest. So I'll erase all the little dots I did here. Okay, all those dots were just to show you where I'm counting, as you probably noticed previously. And what I like to do this is I start with the smallest number, and as I rewrite them, I cross them out up top here. So we'll start, we know the smallest number is 8. So we see we have 8 as our first number. So I'll cross it out. There's only one 8 in this list, so we move to the next, which is 9. So we see we have 3 9s. So I will cross, 4 9s. See, this is why I crossed them out. So we add the 9s. Our next number is 10. Okay. So I see a 10 here, 2, 3 10s. 11, we see 1, 2, 3, and 4. 12, we see 1, 2, 3, 4, 5. And 13, we see 1, 2, 3 times. So with them now in order, we can find the median and the mode. Okay, so the median, we have 20 values. So that's an even number, meaning we don't have a value that's dead center. We have the two values closest to that, which would be the 10th and the 11th values. Okay, so if we count that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we get to 11, and the 11th value is also 11. So they're the same value. So if you have two values, your median is the average of those two, which would be 11 plus 11, divided by 2, since there's two numbers that we're finding the average of. So that would just give you the same value of 11, since the number's the same. But if they weren't the same, that calculation would still apply. For the mode, it's the number that we see the most times. So we have 8 once, 9 4 times, so currently it looks like it's 9, 10 3 times, 11 4 times, 12 5 times, so now it looks like it's 12, and 13 3 times. So since 12 happens 5 times, the mode is 12, since that is the number you see most often. Okay? So what you're seeing here is us doing this by hand. This is also something that can be calculated using Microsoft Excel. Okay? So our next set of data, a lot smaller data set than previous. Find the range, mean, median, and mode of the following data set. Okay? So we'll start by looking at the range. Okay? So I did the first example kind of going through each number. What you look for is, again, what your smallest number is here. And we start in 1, seems to be the smallest. We go to the next value, 5, 4, 2, 6, 2, 1, 1, 5, 3. There's nothing smaller than 1, right? So if we start by calculating our range, I'll switch back to red. Remember, it's equal to, I'll put 1 at the second term because it's the largest minus the smallest. So our largest number, you could just look at this data set and see that it's 6. Or you can go through and say, okay, we have 1 and then 5, which is larger, so it's 5. 4, 2, 6, which is the largest so far. And there's nothing larger than 6, 2, 1, 1, 5, and 3. So our range is 6 minus 1, which is 5, same as our last example. Our mean is the sum of all these values divided by the total number of values. I'm calling it F here. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So F is 10. And if you add up all these values, you get 1 plus 5 plus 4 all the way through. If you add them all up, you get a total of 30 divided by 10 values, or our mean is equal to 3. Okay? For our median and our mode, okay, again, we have to arrange it from smallest to largest. Smallest is 1. So we'll start with 1s, and I see 3 of them here. Again, I'll erase all the dots. We have 1, 1, and 1, again, crossing them out. 2, we have 2 of them. 3, we have just 1. 4, we have just 1. 5, we have 2. And 6, we have just 1. Okay? So now to find our median and our mode. For our median, again, we have 10 values, so we're looking halfway through, which is between the 5th and the 6th values. So our 5th value, if we count in, is 2, and our 6th value is 3. So unlike the last example, we do not have the same term, which means we have to add the two together and divide. So our median is 2 plus 3 divided by 2, okay, because we're finding the average, which gives us a median of 2.5. For our mode, we have the number that you see most often. We have 3 1s, 2 2s, 1 3, 1 4, 2 5s, and 1 6, which means the mode must be 1, and it's the only value that you see here 3 times. Okay, so it's the value that occurs most often. All right. So now that we've looked kind of at the mean, median, mode, and the range, the next item I want to talk about is the standard deviation. This is a very important measure in statistics because it looks at how the data is dispersed compared to the mean value. In other words, how close are all of your data points to that mean value, right? Remember, the mean, which we call x bar, is simply the average. It's the sum of the x terms divided by f, okay? So all it is adding all of them up and dividing by the total number of terms. So we don't know where that average is in relation to all of the other data. And the standard deviation helps us to see that, okay? So this is the formula for the standard deviation. I don't want you to be kind of, there's a lot of terms here, and I want you to kind of be intimidated by it. And a lot of you, or some of you, have likely seen this formula before. So our standard deviation, which by what I call this little O symbol here, it's a Greek symbol. It's equal to the square root of, in the numerator, we have the sum of x minus x bar, all squared. And it's divided by n minus 1. Okay, so I'm going to explain now what each of these terms means. Okay, so x in this term is each data point. Okay, so if you had data points, 1, 2, 2, 3, 4, and 5, each of these data points would be an x term. Okay, x bar is the mean or the average. I've already seen how to calculate that. N is your total number of terms, okay, which is similar to the term you saw in the previous line, f. And the sum symbol here is saying that you actually have to take each value of x and subtract it from the mean and then square it. And you add all of those together. Remember, we had the sum when we talked about the mean. It was the sum of all the x terms. Okay, divided by our total number of terms. Instead, we have to do this for each individual term. The term x minus that mean, okay, and then square it and add all those together. So you'll see when I do an example that it is a lot of math. Usually it's easier to do it in a table form. But what it does is it actually looks at this x minus x bar term, looks at how far away a value is compared to the mean value. Okay, so it's adding all those differences up because it wants to see if it's very far away from the mean, this value x minus x bar would be very large, right? Because the difference between those two terms would be large. If it's small, then it means the difference between those two terms is small, and it means your standard deviation overall would be a lower value. Okay? So I want to give you just a written example to kind of explain, a little bit more about what this means. So the standard deviation is very important because, like I said, you want to see how close your results are to the average, or the other term you've seen is the mean. So, for example, let's say that you have a class average of 70%, or 70 out of 100. If your standard deviation was 20, that means that about 2/3 of your class, I'll explain later in our next lesson why it's 2/3, means that they scored between 50 and 90%. In other words, the standard deviation means they scored within 20 points less than the mean and 20 points more than the mean. Okay, that's a wide range. 2/3 of your class scored between 50 and 90%, which means the grades were pretty spread out. There wasn't, a grade that a lot of people ended up obtaining. By contrast, if that standard deviation was down to only 5, then again, 2/3 of the class, and I will explain what I mean by 2/3, why it's 2/3 in the next lesson. They scored between 65 and 75 now. Again, remember, it's above or below this value of 70. So now you have 70 minus 5 gives us 65. 70 plus 5 gives you 75. So a smaller standard deviation means that your grades are far closer, right? Now, that threshold is between 65 and 75 versus 50 and 90. So if you want to talk about kind of what that means is if you got around the class average, you probably got really close to your buddy in terms of your grade, okay? Because your standard deviation was close, and it meant that a higher majority of you scored within a similar range, okay? So in order to calculate this, again, I showed you the formula. I encourage you to use these steps, all right? So the first step is to find the mean. Again, remember, the mean is equal to the sum of all your terms divided by f, or the total number of terms. You want to write it with a similar notation, the sum of x divided by n. Remember, because we have n in this formula here. Next, you're going to subtract the mean from each number in the data set individually. Okay, so you're going to see in our next slide, when we do an example, you have all of your x terms, and then usually in your table you have a second column that says the x minus x bar squared, okay, where you actually calculate it for each individual term, and then at the end you can add it up, okay? So that's steps 2 and 3, because you subtract the mean and then you square it, okay? Remember, taking advantage of this formula. Step 4 is to add up all those values. That's where this sum symbol comes in. So you're going to add up each of these x minus x bar squared terms together, okay? Step 5 is to divide, okay, by n minus 1, which n being the number of terms, or total number of values. And your final step is to simply take the square root of that number. Okay, that number that comes out is your standard deviation. Okay, we're going to see kind of how to use that standard deviation to determine, you know, plus or minus how close it's dispersed compared to the mean. Okay. Okay, so let's look at an example where we calculate the standard deviation, and then we'll talk a little bit of discussion at the end just about kind of what that number means. So remember the math test data I gave you in the first example. So I'm providing it for you again. And this time I want to calculate the standard deviation. Okay, so a couple items to note here, and I'm taking this from our first example. We calculated the mean, x bar, and it was 10.85. We also know that the number, the total number of data values, or I guess number of results in this, which is n in the standard deviation formula, or you saw it as f, so I'll put a slash, it's either one, was equal to 20, okay? So in this case, to calculate the standard deviation, remember our formula was equal to the sum of x minus x bar squared divided by n minus 1, and it's the square root of all of those terms kind of added together, okay? So what I'm going to do is I'm actually going to write all of our values of x, just as they're written here, okay? So 12, 10, 13, 13. I'm just going to keep writing them. Okay? And for each one of these, I'm going to do x minus x bar. So to show you examples for each one of these, which I will, remember we have values from 8 to 13. So once we calculate it for one of these values of 12, we can put it in each of the pieces in the table for every other value of 12. So we only have to calculate this for each individual number. Okay, so that means we have to do it for x equals 8, 9, 10, 11, 12, and 13. Okay, so for x equals 8, our x minus x bar term is 8 minus our mean, 10.85 squared. For 9, it's 9 minus 10.85 squared. And it keeps going. So for 10, 10 minus 10.85 squared. 11 minus 10, sorry, I just kept kind of writing, minus 10.85 squared for 11. Then we have 12 minus 10.85 squared for 12. And 13 minus 10.85 squared, okay, for 13. So for each one of these, for 8, we get 8.1225. For 9, 3.4225. For 10, again, I'm just putting these in my calculator. We get 0.7225. For 11, 0.0225. You can see how these numbers are different. We're going to talk about kind of why that's the case in just a second. So for 12, we get 1.3225. And for 13, 4.6225. Okay? So you can see that the numbers that are farther away from the mean, okay, so 8 is almost 3 away from the mean because the mean is 10.85. So the number here is much larger. For values closer to the mean, like 11 minus 10.85 is only 0.15. So the value here for x minus x bar is very small. So as you can see, if you think about this a little bit further, the closer your data is to the mean, the smaller each of these x minus x bar terms will be. So when you add them all up, going back to our formula, you're adding up all of these x minus x bar terms. If you add them all up and they're all small numbers, your standard deviation is going to be very small. If they're all large numbers, then your standard deviation is going to be very large. Okay? So what I'm going to do now is take these values and simply place them in this table here. This table is just used to tabulate this data. So for x is 8, here we have 8.1225, so we're going to put it in here, 8.1225. For 9, we have 3.4225. I'm going to put it in each of the cells that has 9. For 10, it's 0.7225. So, starting at the top, everywhere I see a 10, I'm going to write that in. Okay. For 11, it's 0.0225. Again, I'm just going to write that in each point. For 12, it's 1.3225. So in each spot where there's a 12. And lastly, we have 13, which is 4.6225. Okay, so this looks like a lot of numbers, but all we're going to do is simply add up all of those terms. So if you're doing it on your calculator, you may have to do it in multiple steps. It just depends on how many numbers your calculator allows you to input at once. Okay? If you add all of these up, then what you get is the sum of x minus x bar squared, right? Because you're adding up all the x minus x bar squared terms. If you do that, then you get 44.55. Okay? Again, that's just the sum of all the terms in this second column here. So knowing that, that is the key to solving this standard deviation formula. So now, to solve for it, we substitute our values in. So the term in the numerator, again, is this sum, 44.55. And it's divided by our number of terms, 20 minus 1. So if we do that, what we get is the square root of 2.3447. That's if you divide that out. And that gives you a value of approximately 1.53. Okay? So with a standard deviation of 1.53, what that's saying is again, we'll talk about why it's typically 2/3 or approximately 68%. So 68% of students would typically fall within one standard deviation. If this was what's called a normal distribution, which we're going to talk about in the next lesson. So what that means is they will be, plus or minus this in relation to the mean. So they'd either be 10.85 plus 1.53, which is they'd either get around 12.38 at the max, or at the minimum, they would get 10.85 minus that standard deviation. Okay, and that gives you 9.32. So this is showing you plus or minus one standard deviation from the mean. Okay. Again, that's all compiled. This is all done by hand. This is another feature that if you have this data compiled, even just the X values, you can calculate the standard deviation using Microsoft Excel. And I recommend you try doing these by hand, and I do that just to help you understand this formula. But overall, especially when you're in the workplace, please don't do them by hand. Please input the data into something like Microsoft Excel to find the standard deviation. Okay. So that was all that I wanted to go through for your second lesson. We finished that standard deviation. It's going to be really important that you understand the standard deviation concept for when we start into our third lesson. Okay, our third lesson is going to talk about what are called normal distributions. So our third lesson is going to explain why I wrote the 2/3 and 68%, okay, are within one standard deviation of the mean. I'm going to explain why that number is that number in the next lesson. Okay, so in the meantime, give a try to these practice problems. They give you sets of data in these exercises to calculate. And if you have any questions, send me a message on Teams or send me an email. Thanks, everybody.